busy, buzzing Singapore, a modern and industrious city-state with a high ratio of young women postponing families for a life at work. It's a trade-off some come to regret. Like in other modern societies, birth rates here are falling, and fertility research is booming. Singapore's world-renowned fertility clinic at the National University Hospital has helped thousands of parents turn the dream of a family into reality. But for some mothers, the stigma of childlessness is so painful, they refuse to show their faces.
I feel that it's very empty, and I find that a family is not complete without children. I'm very determined, so I keep trying.
After 10 years trying to conceive, she's come to the right place. In 1983, embryologists here were among the first in the world to perform in-vitro fertilisation. Since then, experts like Professor P.C. Wong have seen demand for test tube babies soar.
Women are getting married later and later. And even after they got married, they're postponing childbearing to a later stage. And as we all know, fertility reduces with age. And so the older the women come in, the tougher it is, the higher the fertility problems.
Business is booming, and the growing demand for IVF over the past few decades has helped these doctors push their science ever further. In 1988, the Singapore team was the first in the world to culture human uterus cells. In 1991, the world's first baby, born from an embryo grown in a simulated fallopian tube. And in 1994, the Singapore team documented the world's first isolation of stem cells from 5-day-old human embryos. Researchers had noticed that many of the newly fertilized embryos, or blastocysts, were dying just days after implantation. But when they tried to mimic Mother Nature, by culturing the blastocysts with fallopian tube cells, many survived to day 6.
The blastocyst transfer has a very high pregnancy rates now. Over the last year and a half now, we are chalking up between 45 to 50% pregnancy rates.
It was a much bigger breakthrough than these doctors first realized. At day 4, the human embryo starts making stem cells. And the isolation of stem cells raises the possibility that we might one day be able to grow replacement organs on demand.
The blastocyst could be a source of stem cells. We were able to now grow stem cells and stem cell lines now. In other words, to get them to grow, keep on duplicating without stopping. I mean, they keep on replicating.
For decades, researchers have chased the stem cell problem like a holy grail. The umbilical cord is one source of stem cells. Stem cells are the all-purpose building blocks of the human body. They are the cells that eventually grow into all other cells, and harnessing them is a quantum leap for medicine.
I think we have in our hands right now cells that can be directed into heart cells and nerve cells. I think downstream over the next 5 years, we should be able to develop them into pancreatic cells for treatment of diabetes, skin cells for the treatment of burns, and so on.
Professor Arif Bongso was the first to isolate these stem cells. He says the implications are huge, the opportunities almost unlimited.
There are so many people waiting for heart transplants and those suffering with nervous diseases like Parkinson's, etc., and cancer, for example. And we need to take control of these diseases.
Taking control is the next challenge, and researchers here in Singapore are now at the forefront of that global race for control. Their goal, to force the stem cells to become whatever kind of cell the patient needs. The harnessed stem cells are already being tested. Injected into brains crippled by Parkinson's, they become brain cells. Inserted into a sick patient's heart, they become healthy heart cells.
like all science, all good science, you dream of an idea and then you hope that one day this will bear fruit. And I must honestly say at that time the interest was there, or at least the thoughts were there that stem cells may be useful. But I never ever dreamt that it will draw so much of interest right now and so many people excited. It's a buzzword today, stem cells.
And so the race to create life in a test tube has led us into the brave new world of building body parts on demand. And it's hoped, one in which many of our most deadly diseases are eradicated before these babies even contract them.